The jacket contains 20 IMUs and 8 infrared sensors. Each body segment is covered by at least 2 IMUs. Infrareds are placed between the torso and sleeves. All the wirings are covered by an extra slipped layer inside the jacket. Because of the sensor density, 3 separate CPUs are pulling the data and sending them with UDP packets. On the pants, there are 8 IMUs and 8 infrared sensors. IMUs cover the lower and upper leg while the infrared sensors face each other in the middle. One CPU with Wi-Fi module is located on the hip part of the pants, since it is the most stable position during motion. For each shoe, one CPU is connected with 2 IMUs and 1 infrared sensor. 2 IMUs locate at 2 sides of the shoe, and the infrared sensor is on top of the toes. An independent battery powers all electronics on one shoe. Same as shoes, gloves have their individual CPUs and batteries. There are only 2 IMUs on the hat, no infrared sensors. In the studio, all hardware is being charged at the charging station. The two connects locate at 2 corners of the studio to capture ground truth motion. The capture volume is marked by the blue box on the floor, while the T-shaped marker denotes where the subject should stand. In the front side of the studio, a wireless router receives all UDP packets. The subject faces a flat-screen TV, which shows the example motion the subject should follow and the live video feed from a video camera. On the other side is the second connect. The whiteboard is used to calibrate the two connects so that the two streams of point cloud data could be registered to the same global map. We are using IPySoft to calibrate and for ground truth collection. Ground truth collection is only based on depth sensing, so no markers are necessary to be mounted on the subject. Each subject is supposed to wear a pair of compression suits as a base layer before they put on the hardware. All subjects perform a T-pose at the beginning of all the motions. This is to calibrate the displacement between the IMUs and the body segments. All CPUs are pulling data through the multiplexers from the individual sensors, then compose and send UDP messages to the router. The subjects need to perform 5 different motions for multiple times. They are upper arm motion, lower arm motion, arm swing, boxing, and working. The subject can monitor his or her motion through the screen by comparing his or her motion in the live video feed with the actor whom he or she is supposed to follow. In the control center, the operator could monitor the subject's motion through a mirrored screen, start and stop the example trial for each motion. The UDP packets are collected by a Python logger and saved as text file on a computer through Wi-Fi connection to the router. The master IPySoft recorder is displayed next to the UDP data logger. This is the final structure of the dataset. The dataset is composed of the data and ground truth. Ground truth is in BVH format, provided by IPySoft Motion Capture Studio. The motion files are stripped from the BVH file. It contains the joint angle motion values only, not the skeletal hierarchical structure. Each data frame is composed of an absolute timestamp and 9 packets from all 9 CPUs. Each single UDP packet contains its relative timestamp and then the data from all IMUs and infrared sensors. IMU data is in the order of accelerometer, magnetometer, gyroscope, and temperature. The first 3 has 3 degrees of freedom, and the data is in XYZ order. Infrared sensor data contains the proximity value.